Welcome back to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to be looking at organic chemistry, particularly one of the harder topics in organic chemistry, or at least students find it more difficult, which is condensation polymerization. In other words, the forming of esters. Let's remind ourselves that organic chemistry is chemistry involving substances, carbon-based substances. Okay, so organic chemistry is chemistry involving carbon-based substances such as methane, which you will know about, ethane. These are all organic molecules because they involve carbon. So that is one functional group, which is alkanes. You also should know about alkenes, which have a double bond. They're unsaturated, whereas the alkanes are saturated. But you should also know at this level about alcohols. For example, methanol, which has the OH functional group. And you should know about carboxylic acids, which has a carbonyl group, which is the C double bond O, attached to a hydroxide group, an OH. And I'm just going to put an R, which means any chain of carbon. And we call these carboxylic acids. They're weak acids. And it's these two groups, the alcohol and the carboxylic acid, that will participate in the condensation polymerization reactions. So let's look at that and what that is all about. Let's take, for example, an alcohol such as ethanol, and there's the hydroxide group at the end. Let's put the hydrogens on. Carbon can only have 4 bonds, so you can see the carbon that's attached to the alcohol here has 4 bonds to it. And we're going to react that with a carboxylic acid. We know it's a carboxylic acid because it has the carboxyl group at the end. In this case, it's ethanoic acid. So we have ethanol, not ethanol, ethanol, plus ethanoic acid. We have an alcohol plus a carboxylic acid. When these two react together, they will form an ester. So when they react together, they form an ester. Now an ester bond, I'll put over here, an ester bond or an ester link is when you have a carbon that's attached to an oxygen, which is then attached to another carbon, like that. That will form an ester bond or an ester link. So let's see how we can form this ester link between ethanol and ethanoic acid. So a good way to remember it is that the double bond here on the carboxylic acid is where you're going to get 2 things leaving. In this case, it's the oxygen and the hydrogen. And here, this has a single bond attached to the oxygen. It's where you're going to get one thing leaving, like that. And this is going to form an ester bond. So this carbon is going to attach to this hydrogen, which I'm going to show over here, the product of the two. So I'm going to redraw. This is my alcohol, C to C to O, and that's going to attach to the carboxylic acid. Remember, carbon has 4 bonds, so we're putting in all the H's. And we call this ethyl ethanoate. The second part of the name always comes from the length of the carboxylic acid. Ethyl ethanoate. Now we have to look and see that the H hydrogen here and the OH here have been removed. So we also will get water as a small molecule that comes off as a result of this condensation polymerization. This is where the term condensation comes from, because you're forming small molecules of water, in this case 1 mole of water. Let's look at another example. So here in this example, we have methanol that's going to react with ethanoic acid. We know it's ethanoic acid because we can see the carboxylic acid functional group there. As I said before, it makes it very easy. This oxygen has 2 bonds, so we're going to take these 2 atoms off of the carboxylic acid. This oxygen has 1 bond attached, so we're going to take one of these off, and that is where they're going to come down and they're going to form the water from the condensation reaction. But how about the ester? So we simply then connect up the carbon to the oxygen. So I can draw it this way. I'll do the alcohol first. I put the remainder of the alcohol, and that's the oxygen. And then I connect it to the carboxylic acid here on the other side. And remember, we said how to name it, that it is the carboxylic acid that is the surname, basically. So this is going to be methyl or methyl ethanoate. And that is the ester because it's formed an ester link here, which is a carbon to an oxygen to a carbon. Now, why is the term polymerization used when it comes to forming these esters? Well, the reason is that we can use the bonding between these 2 types of molecules to form a long chain polymer. So for example, here we have an alcohol that's called a diol, di meaning 2, because it has 2 alcohol groups on both sides. We also have on this side a dicarboxylic acid because it has 2 carboxylic groups on both sides. You can see here. And by using condensation polymerization and forming an ester, we can link these 2 together So for example, on this side, we could link that together. And then as well as on the other side, we could link that together. And that would form a long polymer chain that we would write like this. We're going to make the ester bond, and that's going to connect to the carboxylic acid, which would then connect to another one. And we show that by using square brackets and the letter N to say it's going to be a repeating chain. And this is what we call a polymer, because it will be a long repeating chain of this particular monomer.